Okay, so here we're going to do simplifying rational polynomial expressions with multiplication. I guess I shouldn't even call it simplifying, just say multiplying RPEs. And you're going to find that multiplying and dividing, there's nothing to it other than just the most important thing is factor. You're going to hear me say this a lot in this stuff because that is the number one thing with rational functions, rational expressions when you're simplifying them. So this is going to look a lot like assignment A and B where we just simplify because that's really all it is. Because if you look, when you multiply fractions, you're really just multiplying straight across. We don't even really need to separate these two things because we could multiply and have 15ab squared c over 6a cubed bc squared if we really want it. Now, we're not going to just for the intention of the assignment. But factor is step 1, cancel is step 2. That's what it comes down to, okay? So when I look here, I've got monomials. So there's nothing I can really factor this. So because it's monomials, I can just cancel anything in the top with anything in the bottom that works. Now, if it was a binomial or a polynomial, like a trinomial, I would have to have the exact same binomial as I do in the bottom. Or if it was a trinomial or something like that. You can't just cancel certain parts of a polynomial, if that makes sense. So if I had like x minus 2 over 2, I can't cancel the 2's. It would have to be x minus 2 on the top and x minus 2 on the bottom. So let's get going with this monomial one because this one's pretty straightforward. I can see I can reduce a 3 and a 6 to 1/2. I can also see I've got a b downstairs. I can cancel that with one of the b's there. I've got an a upstairs that I can cancel with one of these a's here and be left with a squared. Here, I'll cancel that 3 out better. And I've also got a c upstairs that I can cancel with one of the c's. There's nothing else I can reduce. So my final answer when I multiply this quote-unquote polynomial, this RPE, I get 5b left over upstairs over, I've got 2, I always put my coefficients in the front, a squared, my b's gone in the bottom, and I have a c left over. And now I look at that answer and I look and say, okay, there's nothing else I can reduce. I'm finished. Okay, so that was a pretty straightforward one. I like to start with those ones just to show you that monomials you can go to town on. But in this case, there was no factoring. So let's go to the next example. We've got factoring all over the place. I got a trinomial easy on the top. I got a GCF in the bottom there. I got a monomial on one side. I got a difference of squares in the bottom. So I'm just going to factor this first. Just factor everything. Don't even have to think about it. So up top, I got a trinomial easy of x plus 2, x plus 3, over, and GCF at 2 out of the bottom there. So I get 2x plus 3 times 4x, a monomial, so we don't even factor that, over difference of squares, x minus 2, x plus 2. Just like so. So now I got to look and I got to cancel. Now remember what I said. Remember what I said about canceling top and bottom. So the first thing I notice is this monomial, 4 over 2. Because those are monomials, I can just cancel them. Now they have to be top and bottom. So 4 divided by 2 is 2. So it reduces. There's no other monomial x in this question, so I can't simplify that x that's with that 4. Okay, so now I'm looking at the binomials. So I can see right away I've got an x plus 2 and an x plus 2. You notice they're identical. That's why I can cancel. Just like this x plus 3 and this x plus 3. Now the x minus 2, a lot of people screw this up. They think, hey, I can cancel that x with this x. No, you can't, because that x minus 2 is one whole binomial. It's its own term. So your final answer now looks like this. 2x over x minus 2. And you're done. Do not try to simplify that any further, because that is a monomial on top and a binomial on the bottom. And in order to cancel a binomial, it has to be exactly the same as the binomial that would be on the top. So there's your final answer. And that is about as hard as simplifying RPEs with multiplication can get.